So let us start this class, and this is lecture number 2 that we are doing of relative motion. If you remember and if we recollect, what had we done in the previous class? In the previous class, we had seen some problems of relative motion in 2 dimension. We had seen how do you find out and why do you have to see relative motion between the two bodies, and we also got
1 minute.
okay now.
No, sir.
What happened now? Okay.
Yes, sir.
Okay, and we had seen how do you find out the position vector of any particle A with respect to any other particle B? How do you find out velocity of A with respect to B? How do we find out acceleration of A with respect to B? We remember this?
Yes, sir.
Okay. We'd also seen equation of motion for various cases, and we had seen that there is no difference between the equation that we did previously and the equation that we are doing now. Yes, sir? Okay. We'd also seen that whatever be the case, whether it is equation in 1D, equation in 2D, or equation in 3D, motion in 2D or 3D, the equations are going to remain same. Do we remember this?
Yes, sir.
So the heading of the class is motion in 2D, and here is the first question. And I think you know enough about about relative motion that you should be able to solve this question, and the question comes right away. I think it is a question from your module only, if I'm not mistaken. Do you have the module with you? Yes? No? I think this is a question from your module itself. I think it would be example number 12 in relative motion if you have that module. Anyways, you have the module or not, you don't have to write the question as such. You just solve the question as it is. An old man, the blue one is an old man. He's not looking like an old man. He's looking more like Sherlock Holmes. An old man and a boy are walking towards each other. So that is motion in 1D because they are walking in a straight line. And then there's a bird which is flying over them as shown in the figure. Remember, your I means x-axis and y means j-axis are drawn in this way. A bird is flying over them. You have to find the velocity of tree, bird, and old man as seen by the boy. That is your first question, the yellow one. Velocity of tree, bird, and old man. So there are 4 characters here. All are living beings. One is not a living being, one is a living thing. Tree. So you have to find the velocity of tree, bird, and old man as seen by the boy. And your time starts now. And how you got to do this? I've already told you how to find it out. Here you go, and you have 2 minutes. And as you all know, time is a luxury that we don't have. Do it fast. I don't see the boys doing anything. See, if you're waiting for a miracle to happen, that all of a sudden the question will solve itself on the whiteboard, that is not going to happen. The only miracle that God has created is you right now sitting there. You are the miracle. And after you being created, God has decided not to do any miracles for you. So you have to do the miracle for yourself. Try. I should see all the heads down, not on the board, because answers are not going to appear from the board. Look at the board, solve the question, give me the answer so that I can move ahead. Have you done the first part? Velocity of no one? Done or gone? Okay, I will help you with the first part. Let us write everything in terms of I and J, because this is the motion is not going to happen on one line. It is happening on a plane. What is the velocity of tree? Now, whenever I write anything, I'm writing it with respect to ground. So what is the velocity of tree with respect to ground? Vectorly, I'm writing. Yes. With respect to ground, what is the velocity of tree? Obviously, the tree does not move. Yes or no?
Yes.
So velocity of tree, I have not written G. G stands for ground. I have not written that. I want to save some time and some precious ink. This is not an ink pen at least. Okay, anyways. What is the velocity of boy? VB. With respect to ground, I am talking. Yes. Look at this. Yes, 16. How do I write it? Look at 16 and look at this.
16 I cap, sir.
Yes, you write it as 16 I cap. This is no rocket science, beta. This is simple physics. Okay, velocity of boy with respect to ground. Let us move ahead and write the velocity of man, old man. It's not looking like an old man, so I'll just call him man, old person. Could have made a different diagram for an old person. What is the velocity of man with respect to ground? Look at this.
-2, sir. -2 I cap.
That is better. -2I. What is the velocity of bird? Now bird and boy will become same. So I write eagle. I make the bird as eagle. Velocity of eagle, VE. Yes. Again, remember, it is with respect to ground. We have already done hard work for us. It was 20 meter per second in this direction. They have resolved it vectorly. One vector is going like this, and the other vector is going like this. Yes.
Yes.
What, sir? Tell me, sir. What is the velocity of bird? I mean eagle with respect to ground?
+16 I cap plus 12 J cap, sir.
16I plus 12J. These are the velocities of all the four concerned people or living things on this. Now what I got to see is you have to find the velocity of everything with respect to boy. Boy. With respect to boy means with respect to this. Now can I have your answers? What will be the velocity of tree with respect to boy? So I'll write it as velocity of B T. Velocity of boy. That will be velocity of boy with respect to tree. Sorry. Velocity of tree with respect to boy. TB. What is VTB?
-16 I cap.
So velocity of tree minus velocity of boy. So it is -16 I cap. Everyone understands this?
Yes, sir.
Then I write the second thing, velocity of bird. So that is E with respect to B.
+12 J cap.
So it will be velocity of E 16I plus 12J minus 16I. So it will be simply 12J hat. Yes or no?
Yes, sir.
The last thing that is remaining is velocity of man with respect to boy. So that will be velocity of man minus velocity of boy.
Sir, V is not visible, sir.
What beta?
V is not visible on screen, sir.
B is not visible on screen.
Please scroll up, sir.
Okay. Now Can you see it now?
Yes, sir.
Okay, I'll just write it here. Velocity of, you can see this now? Man with respect to boy. Just
Minus 14 I cap.
so that will be velocity of man is minus velocity of man with respect to boy. So minus 2I minus 16I. So that is not 14, it is minus 18I. Do we understand this?
Yes, sir.
Everyone understands this?
Yes, sir.
So now what you'll do is you will do the green question on your own and tell me the answers. Find the velocity of tree, bird, and boy as seen by the old man. Do it fast and tell me the answer. Do you have your answers? Okay. So the first one, velocity of tree with respect to the man.
Plus 2 I cap.
So the tree will appear coming like this. It does not happen actually, but this is how the man will feel. Plus 2 I cap. Yes, velocity of the bird E with respect to man.
18 I cap plus 12 J cap. 18 I cap plus 12 J cap.
18 I cap plus 12 J cap. Everyone got the same answer? The last but not the least, velocity of boy with respect to the man.
18 I cap.
See, it was minus 18 I cap here. It will be plus 18 I cap here. All of us understand this, yes or no? Once we get this, from here you can find out the magnitude of velocity. For example, the magnitude of this velocity, which I'll write it as V. The magnitude of this velocity, I will write it as V of tree with respect to M. The magnitude is simply 2. Magnitude of the bird E with respect to M will be under root of 18 square plus 12 square. Do we all understand this, what I'm doing here? Magnitude of velocity of boy with respect to man is 18 meter per second. Everyone understands this?
Yes, sir.
Because in the examination hall, it is not necessary that the answer is given in terms of your I and J. The answer may be asked only for the magnitude of velocity, and then they can ask you the angle as well. So they can have two options, one for magnitude and one for the angle. Do we understand this? Remember, nothing has changed, whether it is motion in 1D, motion in 2D, or motion in any D. The concept of relative motion remains same, and you must understand that from the first day we have been studying relative motion. The only thing was we were studying all the motion with respect to ground, because ground frame was good enough to solve this. Can I move on to the next question? Yes or no? Oops, something wrong here. Today, nothing is working as the way it was supposed to work. Okay, can I move on to the next question?
Yes, sir.
And without wasting any time, fatafat give me the answer. You don't have to write the question, look at the question, look at the diagram, draw the diagram, and just tell me the answer. Object A and B both have same speed of 10 meter per second. A is moving towards east. You are lucky that east, north, east, west, north, south is given to you. A is moving towards east while B is moving towards north, starting from the same point as shown. Find velocity of A with respect to B. And you have 2 minutes to do this. Yes, my dear friends, do we have answers
10
for this
root
one?
2, 10 root 2 meter per second.
10 root 2 meter per second. There are a number of ways in which you can find it. Remember, this is always your x-axis and this is always your y-axis. Yes or no? So to solve this, you can straight away write it like this. Velocity of A with respect to ground, I'm just writing it as A, is 10I. Velocity of B with respect to ground, VB, is 10J. What I had to find out, what velocity of A with respect to B. So velocity of A with respect to B will be velocity of A minus velocity of B. So the answer would be 10I minus 10J in the form of vector. You can find the magnitude of this velocity, that will be equal to 10 root 2. You can also find the angle. How will? That is important. How will A look to B? Can you tell me the angle? How does it look like?
45 degrees
Where 45 degrees?
due to east.
Yeah, like this, 45 degrees. Like this.
Yes, sir.
Everyone agrees on this? It looks like this. How does A look to B? Looks like this? No, it does not look like this. This is wrong. Look at this. Look at this, my dear friends. Look at the vector here. Look at the vector here. Now reframe your answer again. How does A look to B? Tell me, how does A look to B? And it is important that you understand directions, otherwise you will make mistakes in the examination hall. Yes, my dear friends. How does A look to B? 10 is I.
Due to south, sir.
It would look like this at an angle of 45 degrees. Do we understand this? Because J is negative, I is positive. I is positive means east according to this diagram. J is negative, that means south. So it will look like this. Do we understand this, or just gone above and saying bye bye? I'm going.
Yes, sir.
Okay, well done. It's important that you understand vectors in terms of directions, because if you don't understand them in terms of direction, you have understood them only half. Can you move on to the next question?
Yes, sir.
And this is the next one. I think this is again from your module. Two particles A and B are projected in air, throw it in air, with speed of 30 meter per second. A is thrown with a speed of 30 meter per second with an angle of 37 degrees, as you can see, while B is thrown with 40 meter per second at an angle of 53 degrees from the horizontal, as shown in the figure. What is the separation between them after 1 second? This question, exactly this language was different. This has come in JEE Advanced. I'll give you 1 minute, 2 minutes to solve this.
50 meters, sir.
Well done. How did you get it?
Sir, the angle between A and B is 90 degrees.
So,
So after 1 second, A travels 30 meters and B travels 40 meters. It will become right angle triangle, and hypotenuse is the magnitude of distance
beta,
between.
they are thrown in air. They are not moving on ground, bacha. So, my dear friend, please understand the question. They are thrown in air. Dung, nang, 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 nang. This goes like this. Pang, 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 pang. This goes like this. Do you understand? Projectile motion, my dear friend, they are not moving in a straight line. Do we understand this? They are thrown up in air. You have not read the question properly, my dear friends. They're thrown up in air. Don't look confused. Don't look sad. Don't look like you can't solve this. Remember, if you look at the question and the first thought that comes to your mind is that this question is tough and you cannot solve it, trust me, no one in the universe can solve it for you. The first thought that should come to your mind when you see any question is that you can solve it. Then only you will be able to solve it. The looks on your face looks like, since I have told you that this question has come in JEE, they were like, oh, now it is not possible for us to solve it. Remember, as soon as I tell you that this question has come in JEE Advanced, you must be happy. Okay, this is a simple question. That's why it has come in JEE. And that is how I can solve it. If the first thought that comes to your mind is it is a tough question, no one can solve it for you. Not you, not me, not anyone else. The surprising factor is that your answer is correct. It is 50 meters. So if you could have guessed, your guess was correct, but your concept was not. And remember, when your guess is correct and your concept is wrong, that's a very, very painful scenario, because that will land you up in deep trouble. Answer is still 50 meters. Yes, that is correct. But also remember that this is parabola. They are thrown up in air. They are not moving in a straight line. And that is the beauty of physics. And that is the beauty of relative motion, my dear friends. I'll give you 1 minute to think about it. And then I shall reveal the magic behind it. Why it is 50 meters. Think about it. Shall I help you?
Acceleration is 0, sir. Between two
What?
particles.
Which acceleration is 0? Acceleration due to gravity. How it is 0?
Sir, when we compare one object with another, the
We
acceler-
are not comparing. You are using the wrong term. We are not comparing. Rephrase the term. Remember, beta, when you say things correctly, then only you understand them correctly. If you say the wrong words, that means you have understood them wrongly. Yes, try again. I understand what you mean to say, but say it in the correct language. Now, to do any question of this nature, what is the fact that you need to remember? Now, if I'm watching this motion becoming this red, oops, where is my red Hulk? If I'm watching this motion, if I'm this red Hulk, it's a difficult motion because both of them are projectiles and they are moving along projectile paths. And for me to understand this motion from ground becomes difficult. But the motion becomes very simple as soon as I what? Become any one of the projectiles. As soon as I become any one of the projectiles, so I become the blue Hulk, let us say, and I become the projectile number A. Now, whatever I am watching now, whatever I am seeing now is with respect to A. Do we understand this? Yes or no? Yes? No. So whatever I am watching now is with respect to A. Now, both of them has been thrown in the air simultaneously, and that is the main point. Both of them had been thrown in the air simultaneously. If you throw one and after some time you throw the other one, then once both of them are in air, then only this thing what I'm going to tell you is valid. If one is flying and the other one is not flying, the motion is different. When both of them are flying, then the motion is different. Do we understand this? If one of them is on ground and the other one is flying, the motion is a projectile motion. Do we understand this? But when both of them are in air, the motion becomes very simple. Now, see, I have become B. I have become A. So this is A. Now remember, this A is not going anywhere. So A is just a point. It does not go anywhere. As soon as I become A, I don't go anywhere. Everything either comes towards me or it goes away from me. I become A. Now, as soon as I become A and I find out the acceleration of B with respect to A, it is also under gravity and I am also under gravity. So the acceleration of B with respect to A becomes 0. It is purely 0. Yes or no? Now, if the acceleration of B with respect to A is 0, the velocity of B with respect to A does not change. So whatever was its initial velocity, it will always remain the same. That means the motion becomes uniform motion with uniform velocity, and that has to be a straight line. Do we understand this?
Yes, sir.
Yes or no? No or yes? Now, just to illustrate my point, this is my x-axis. And this is my y-axis. Now, the question is framed in such a way that both of these velocities are perpendicular. Do we understand this? Both of these velocities are perpendicular. Now, when I become A, what do I see? I will always see B moving perpendicular to me. Yes or no? So, if I change my axis in such a way, just to make this question simpler, remember, what I am trying to do is to make this question simpler, because if I draw the original axis as x and y, the question becomes a bit. So I make my new x-axis like this, which is along the direction of A. Then my other axis goes along y, which is the direction in which B is moving. Yes or no? Now, what will be the velocity of B with respect to A? That will be the velocity of B, 40J minus 30I. Do we understand this?
Yes, sir.
40J minus 30I is the velocity. Both are perpendicular. So the velocity ka magnitude becomes 50. Yes or no? 40J J minus 30I is the velocity of B with respect to A. Because my dear friend, now B is moving like this with 40 meters per second. And now A is moving like this with 30 meters per second. I've just changed the axis so that the question does not look very complicated. Do we understand this?
Yes, sir.
This is how we make questions simpler rather than difficult. I could have done this by taking the original horizontal and vertical as the x and y, but then I'll have to find the components of velocity and it might look a bit confusing. So now the velocity of A with respect to B, no, sorry, B with respect to A simply becomes, my dear friends, how much? It is 40I minus 30J, and it is going to move in a straight line. If I'm here, it will always move perpendicular to me. Yes or no?
Yes, sir.
So what will be the displacement? Just multiply it by 1 because acceleration is 0. So displacement would be 40J minus 30I. What is the magnitude of displacement? That will be the distance between me and him. Yes or no?
Yes, sir.
Time is 1 second. 40 into 1 is 1. Minus 30 into 1 is 1. 40 square plus 30 square. The displacement or the distance between me and between A and B would be 50. Do we understand this?
Yes,
So
sir.
the answer is 50. So what you need to understand as important point from this particular question, and that is the reason why we did this question, is this: when two projectiles are in air, when two projectiles are in air, remember it is only valid when they are both in air. If one is on ground and the other one is in air, this thing doesn't work. When two projectiles are in air, then what? Then the relative motion of one with respect to 2 will always be what? Will be a straight line motion. Do we understand this?
Yes, sir.
As soon as the two projectiles are in air, so if you become one of those projectiles, the other projectile will always move in a straight line. This is assuming that no other force acts on them, and the only force that acts on them is gravity. Do we understand this?
Yes, sir.
I'll give you 1 minute to note this down, and then I might frame a question for you. Meanwhile, I'll frame the question. You write this down. Have you noted it down, bacha? Yes or no?
Yes, sir.
Okay, then this is a famous question that again has been asked many times in many exams. My drawing may not look very revolutionary, but it does the purpose. So what do you see? That gach 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 is a tree, and that small gach 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 is a monkey. This is a monkey, and this is a tree, and this is a shooter. Shoot. Yes. Now the shooter wants to, for God knows what reason, want to shoot the monkey. Right now, but as soon as he fires the shot, monkey sees that the shot has been fired, so monkey starts to fall down under gravity. Monkey just leaves the branch and starts to fall down. There are two or three different ways in which it is asked. I will ask in all the possible ways. First, I'll ask in one way. At what angle should I hold my gun, or should the shooter hold his gun so that even if the monkey falls, the bullet hits the monkey? This question is asked in a different way. The angle is given, and it is said that the monkey is on the tree and the shooter is pointing at the monkey. As soon as he shoots, the monkey drops. Will the bullet hit the monkey? Do you understand? Both questions are similar. So I aim at monkey, the shooter aims at the monkey, but monkey sees that the shooter is trying to kill me. So as soon as he fires, he drops down. Will the bullet hit the monkey? That is one way of asking this question. The other way is, at what angle should I aim so that I hit the monkey even if it falls? The bullet will hit the monkey. And the acceleration due to gravity is 10 meters per second square. You have 2 minutes to tell me the answer. You have to find out this theta in my question, or the question could be put in a different way. Yes, my dear friends. What angle should I shoot so that my bullet hits the monkey? Yes. No one with an answer.
Tan inverse of 4 by 5.
Tan inverse of 4 by 5. That is correct. My tan theta should be equal to 4 by 5. Or in short, it is very simple. If initially I aim towards the monkey, and then I have to probably change the direction of this. Oops, what has happened here? If initially everything has gone. Let something come. If initially I target such that I am targeting the monkey, the bullet is going to hit the monkey no matter what. Why will it hit the monkey, beta? Because as soon as the monkey falls, the bullet has also become a projectile. And both the bullet and the monkey are in free fall. The only difference is monkey is falling straight, but the bullet is going on a parabola. But doesn't matter. If you become the bullet or you become the monkey, your motion is a what motion?
Straight line.
Straight line motion. So if I initially target the monkey, now if I am the monkey, the bullet will always come towards me. Do we understand this? Because initially the bullet was coming towards me. The initial velocity of the bullet was towards me. So whatever I do, if I fall, the bullet is going to hit me. Do we understand this?
Yes, sir.
There is again one more famous question that came way back in a JEE. Similar question. not the monkey falling, but they had two projectiles, and that was a 8-mark or 12-mark question, and the question was like this. I don't remember the exact values. So there was, I think, one tower, and then there was the second tower, and then from one tower, a ball was thrown horizontally, and from the second tower, you have to find out at what angle should you throw the balls that both the balls they collide. Do you understand this? So one ball was thrown horizontally and the other ball was thrown at some angle. You have to find at what angle should I throw this ball so that ball number B hits ball number A. If I tell you that this distance is, let us say X, and if I give you again, this is the JEE Advanced का बहुत पहले का question. This distance is Y1 and this distance is Y2. Can you tell me at what angle should I throw the ball so that this ball and that ball? Again, you must understand that both the balls are thrown simultaneously. At what angle should I throw ball B so that it hits ball A? Obviously, the speed must be enough so that they meet. If the speed is very less, they will not meet. The speed is more than enough for them to meet. At what angle should I throw the ball B so that ball A and B dharang? So, I mean, I'm not asking you to solve the question. What I mean to ask you, since the values are not given, so it might be difficult. How will you solve this question? If you try to solve it by very normal way, you can obviously solve it, but it will take a lot of time. What you got to do is find out. You become any one of the balls, and I will become ball number A. If I become ball number A does not go anywhere. Now, if ball number B has to hit me, the velocity of B with respect to A should be along this line. Do we understand this? That must be the line of velocity of B with respect to A. Velocity of A was given, the speed of B was given. From there, you can find out velocity of B with respect to A, and then you can find out at what angle should I throw this. Do we understand this?
Yes, sir.
So remember, such questions can come. You just have to be careful. Just remember that once the two projectiles are in air, my dear friend, the motion of one with respect to the other is always going to be a
Straight line.
straight line motion. The next type of problem are the famous problems which are known as what? Rain man problem. So rain is falling and a man is walking, and you have to find out at what angle he should hold his umbrella. I've just shown this so that I don't have to waste any time. So basically, the question would be very simple. The man would walk. Again, this Sherlock Holmes, he is now having a umbrella in his hands, and now he's walking. Now this Vm, as you can see, is the velocity of man with respect to ground. Do we understand this? So he's walking like this. And this VR is the velocity of rain with respect to ground. So rain is falling like this and the man is walking like this. Now the question asks you to find out the velocity of, no, they do not ask you to find out the velocity. They will ask you at what angle with the horizontal or with the vertical. They will not ask from the horizontal, they will ask from the vertical. At what angle should he hold his umbrella? And what is the velocity of rain with respect to man? Whatever question they ask, you always have to find out one thing, and that thing is what? That thing is what? That thing is velocity of rain with respect to man. Do we understand this? And how do you find out the velocity of rain with respect to man? Velocity of rain minus velocity of man with respect to ground. Do we understand this?
Yes, sir.
If someone asks you to find out the magnitude, this is how you can find out the magnitude, because in this case both are at 90 degrees. So it is VR square plus VM square ka root, that is the magnitude of velocity, yes or no? Then they can ask you at what angle he should hold his umbrella. So he should hold his umbrella like this. Do you understand this? You should hold this umbrella in this fashion. And they normally ask you at what angle you should hold this umbrella. Remember that angle is always from the y-axis. So if they ask you what is the angle, you just find out the value of tan theta. This tan theta is with the vertical. Therefore, we divide the horizontal Vm, in this case, divided by the velocity of rain. No, I've done ulta. So that will be velocity because it is with the vertical, it will be Vy divided by Vx. I should write it like this. That is better. If they ask you to find out the angle with the horizontal, it is Vx by Vy. Do we understand this?
Yes, sir.
Pakka? Oh, I've written it ulta, yaar. I always do this mistake. It should be with the y you have to find out. So it should be Vx divided by Vy. I wrote it first correctly. Whenever you have to find angle with the x-axis, you divide it by the x component. Whenever you have to find the angle with the y-axis, you divide it by the y component. Do we understand this? I always make a mistake here and there.
Yes,
So
sir.
this is the only question probably that they are going to ask. Everyone knows this? Can I give you a question then? Everyone has noted this down? Give you 2 minutes to note this down. I hope you can note it down. Shall we move on to the question?
Yes, sir.
Question, the first one is very simple. The other one is also simple. The third one is also very simple. Solve it. Rain is falling vertically. Again, whenever the speed of rain is given, it is always given with respect to ground. Else they will tell you. Rain is falling vertically with a speed of 10 meter per second and a man is moving ahead with a velocity of 6 meter per second. Find the angle at which the man should hold his umbrella to avoid getting wet. And again, this angle is always with respect to the vertical. They have asked, they have not told you this. You always find the angle with the vertical. Can you tell me? The answer.
Tan inverse 3/5.
Tan inverse 3/5. Do I need to draw the diagram or do you understand this? Everyone understands this?
Yes, sir.
Then let us see what will happen in the next one. Remember, don't get scared. If you get scared, no one will help you. The first thought that should come to your mind when you see a question is what? The first thought that should come to your mind when you see a question is what? Huh? What is the first thought? The first and the only thought that should come to your mind is this question is simple and you can solve it. Else you will not be able to solve it. This is the next question. A man moving with 5 meter per second observes rain. The language has changed and hence the question. A man moving at 5 meter per second observes rain falling vertically at the rate of 10 meter per second. Find the speed and the direction of rain with respect to ground. And you have 2 minutes to do this. Just my dear friends, do we have an answer? Yes or no? Shall I help you?
No, sir. We're trying. 1 minute more.
Okay. I'll give you 2 more minutes. So how are we supposed to do this? We just draw a simple diagram. And this is a diagram. Velocity of rain with respect to man. How does rain appear to the man? It is appearing to be falling vertically downwards. Yes or no?
Yes, sir.
So I can write velocity of rain with respect to man. It is given here, my dear friend. Man moving with 5 meter per second observes rain falling vertically downwards. So that is velocity of rain with respect to man. It is downwards. It is 10. So I call it minus 10J. Do we understand this? Yes or no?
Yes, sir.
Velocity of man with respect to ground. Let's just write it. It is 5I. Yes or no?
Yes, sir.
I have to find the velocity of rain with respect to ground. As I told you, a simple trick. Just put m in between. That will be velocity of rain with respect to man plus velocity of man with respect to ground. Do you remember this?
Yes, sir.
Take it otherwise. So it is very simple. It will be equal to 5I minus 10J. Do we understand this?
Yes, sir.
That will be velocity of rain with respect to ground. I can now find the magnitude. Magnitude will be speed. Magnitude of velocity is speed. Instantaneous velocity I'm talking about. So the magnitude will be 5 square plus 10 square root. So I think it will be 5 times root 5. Yes or no?
Yes, sir.
Then again, I can find the angle theta with the vertical. That means y-axis. So I'll divide the x component by the y component and I will get tan theta as half. Do we understand this? Yes or no? So
Yes.
that is the actual direction of rain with respect to ground. The rain is not falling vertically downward. It is falling at an angle. Do we understand this?
Yes, sir. Sir, VRG is 5 root 6.
Yeah, beta?
It is 5 root 6, sir, magnitude.
5 root 6. Okay. Do we understand this?
Yes, sir.
So this was rain man problems. We have covered this. I was supposed to take the river boat problems also, but since time has run out and time is a luxury that we don't have, so I will have to stop the class here. I hope you have understood the concept. The concept is no different, whether it is motion in 1D or 2D or 3D or 5D. The things remain same. So in the next class, we will try to wind up relative motions with more questions. And we will then probably, if we are done with this, then probably we can move on to the next chapter. So I'll try to solve all sorts of problems that are possible so that this question and this topic gets locked. So on that note, I will wind up today's class. In today's class, we have seen relative motion in 2 dimensions. We have seen when 2 projectiles are in air, they are always moving in a straight line with respect to each other, and you can have some questions based on this. We have seen rainman problems. Same concept applies everywhere. I hope you enjoyed this class. I'll see you in the next class. Take care. God bless you all.
Thank you, sir.